Right, so today we're going to look at the chapter 2.1 to 2.4 test review. So number 1, it asks us, what is the equation and vertex form of a parabola with vertex 3, -2 that passes through the point 5, -1? Remember, vertex form looks like y equals a times x minus h, quantity squared plus k, where my vertex is h comma k. So first I just want to plug in my vertex. So I get y equals a times x. My vertex form said 3, -2. Remember that the x always goes in the parentheses opposite, so it's a positive 3, so it's going to go at x minus 3, quantity squared minus 2. Now we're going to evaluate at the point 5, -1. So we're simply going to plug in 5 for x and -1 for y and solve for a. So I get -1 equals a times 5 minus 3, quantity squared minus 2. Add 2 to both sides. So I have 1 equals a times 5 minus 3 is 2 squared. So I get 1 equals 4a, divide by 4, a equals 1/4. So my equation in vertex form, f of x equals 1/4, parentheses x minus 3, quantity squared minus 2. There's our vertex form. All right, number 2. Function g is a transformation of the parent function, f of x equals x squared. The graph is a translation right 2 units and up 3 units. Write the equation for g in the form y equals ax squared plus bx plus c. So again, they're telling me here that my vertex is 2, 3. There is no a that we have to worry about here because they didn't tell me that I had a translation of an a. So if I write y equals x minus 2 quantity squared plus 3, and then I want to work that out because I see that they have given it to me in standard form and they want the answer in standard form. So I need to do x minus 2 quantity squared. So I get y equals, remember this is where I'm going to do my shortcut, the first term squared, x squared. Multiply the 2 together and double it. So -2 times x is -2x, doubled -4x. And then the last term squared, -2 squared is plus 4. And then I had that plus 3 on the outside. So now I just combine like terms. Y equals x squared minus 4x plus 7. So that is D. All right, number 3. What is the vertex of the graph of the function f of x equals x squared plus 8x? Remember, we have that equation to find h, okay, the x value of the vertex, which is -b divided by 2a. So h equals, so my b is 8, so -8, because remember -b just means I change the value of b, divided by 2 times a here is 1. So -8 divided by 2, h is -4. So now to find the y value, I simply plug -4 into my equation. So y equals -4 squared plus 8 times -4. So -4 squared is 16. 8 times -4 is minus 32. So 16 minus 32, y is -16. So my vertex is -4, -16. C. All right, so now number 4. The path of a projectile launched from a 20-foot tall tower is modeled by the equation y equals -16x squared plus 32x plus 20. Graph the equation. What is the maximum height in feet reached by the projectile? So very first thing again I want to do, okay, take this equation that they give to me. I need to find out what is my vertex, and then I can graph it. Okay? So once I find my vertex, then we will make an xy table, pick the points. So -16x squared plus 32x plus 20, I want to make my life easier and see, can I factor anything out? I can go ahead and factor out a -4. So if I factor out a -4, I am left with 4x squared minus 8x minus 5. Okay? So now I'm going to 4x squared minus 8x minus 5. I'm going to find my vertex using that same formula. H equals -b divided by 2a. So -b is +8 this time, divided by 2 times 4. So 8 divided by 8 is 1. So now I'm going to plug that back in. So y equals negative 16 times 1 squared, which is just 1, plus 32 times 1 is just 32, plus 20. So I get, let's see, negative 16 plus 50, which is a y value of 36. So my vertex, I know, is at the point 1 comma 36. Okay. So I can go ahead and plot my vertex. So over 1, let's see, this is going in 4s, so this right here would be 36. Over 1 up 36. There's my vertex. So now I want to make an XY table. Remember, my vertex goes in the middle, 1, 36. And now I need to pick a point on both sides of my vertex. So if I pick 0, that's going to be easier if I go smaller. So if I plug 0 into my original equation, 0 squared, that turns out to 0. 32 times 0 turns to 0, and I know I'm at 20. If I go the other direction at 2, I know I'm also at 20, because remember that for each step I go from my vertex, it's always symmetric left to right. So the 0, 20, so let's see. This is 20 right here. And then 2, 20. So I can go ahead and draw the picture of my parabola. So I know that there's the graph. So we did the first thing, graph the equation. And then it says, what is the maximum height in feet reached by the projectile? Remember that the maximum and minimum values are the y values of our vertex. So we can say that the max is at my vertex, the y value is 36 feet. So it reaches a maximum of 36 feet. All right, number 5, use quadratic regression to find a quadratic equation that fits the given points. So this is where we do our graphing calculator. Remember, on the graphing calculator, you go to the stat and then edit in the list, and you put these as your L1 values, these as your L2 values. Then you go back to stat, and then you go over to calculate. Number 5, the quadratic regression. And it will give you A, B, and C. And when you do that, then you end up with f of x equals negative 0.725x squared plus 5.9x plus 7.85. Remember, we also did this on Desmos, where we added the table and put this as x1 and y1. And then the second equation, we had to say y1 is approximately ax1 squared plus bx1 plus c, and then hit enter, and it would give us the exact same thing. All right, number 6, solve the equation x squared plus 7x equals 18. If I'm solving it, that means when does this equal 0? So I need to get everything on the same side. So I make this say x squared plus 7x minus 18 equals 0. Now I need to factor this. This is an easy one to factor because the number in front of x squared is not bigger than 1. So 2 parentheses equals 0, x and x. And I ask myself, what can I multiply together to get negative 18, but add to get a positive 7? Well, I know that 9 and 2 give me 18, and I can get a 7 out of 9 and a 2. I want my bigger number to be positive because I want a 7x, so it's plus 9 minus 2. They didn't ask me to factor, they asked me to solve, so now that's where I set each of my factors equal to 0 and solve. So here I get x equals negative 9, here I get x equals 2. So negative 9 and 2, that was A. All right, let's go to the back of the test review. Number 7, a ball is thrown from the top row of seats in a stadium. The function h of t equals negative 16t squared plus 80t plus 96 gives the height 10 feet of the ball t seconds after it is thrown. How long will it be before the ball hits the ground? Okay, so again, I just need to solve this equation because remember that it's asking me when it hits the ground, so it's looking for when is t equal to 0. Okay, so negative 16t squared plus 80t plus 96. I want to know when does that equal 0. So again, I want to factor it. I want to try to make my life easier. So again, I look for what's the biggest number I can take out. So the GCF, I have a negative 16, an 80, and a 96. 16 goes into all of them. The first one is negative, so I'm always going to pull out a negative. So pull out a negative 16, and I'm left with t squared minus. So 80 divided by negative 16 is 5, so minus 5t. 96 divided by negative 16 is negative 6. So again, now we've made this much easier to factor. So I still have my negative 16 out there. Two sets of parentheses. I'm going to have t and t. What can I multiply together to get a negative 6? But when I add, I get a negative 5. So I know that my two numbers have to be opposite signs. So 6 and 1 are the only ones that are going to work here. I want my bigger number to be negative because it's a negative 5. So t minus 6, t minus 1. Now I'm solving these. Remember that when I solve, when I set everything equal to 0, this, what I factored out, my GCF, really goes away when I'm solving. So I get t minus 6 equals 0, t minus 1 equals 0. So I get t equals 6, and t equals negative 1. This is how long will it be before the ball hits the ground. Remember, these are my times. So here I have 6 seconds, negative 1 seconds. That doesn't make sense. So remember that here my negative answer goes away. So my answer after 6 seconds, the ball hits the ground. Okay. Right, number 8, identify the interval or intervals on which the function y equals x squared plus 9x minus 10 is negative. Okay, so again, remember I need to find my x-intercepts because the graph can only change from positive to negative, okay, where it crosses the x-axis. Right? It has to cross the x-axis and then the y value changes. So I need to find my x-intercepts. So again, I need to factor this. X and x. So what can I multiply together to get negative 10, but add to get a positive 9? Well, that's going to be a 10 and a 1. Again, I want my bigger number positive because I'm looking for plus 9x. X plus 10, x minus 1. When I solve those, I get x equals negative 10 and x equals 1. Those are my x-intercepts. Remember, this is where we test our intervals. I start with a smaller one, negative 10. I want to know what is it doing on the left-hand side. So when x is less than negative 10, I want to know what it's doing. I want to know what it's doing now between my x-intercepts, negative 10 and 1, and then on the right-hand side of 1. So this is where we pick numbers and plug in to our original equation. So x is less than negative 10. I need to pick a number smaller than negative 10. I'll just go with negative 11. Plug into the equation. Negative 11 squared plus 9 times negative 11 minus 10. So negative 11 squared, that's 121, minus 99 minus 10. So I don't actually need the number, I just need to know is it positive or negative. I see this number is going to be positive. Pick a number between negative 10 and 1. Here, 0 is in between those two. 0 is going to be the easiest to pick. So 0 squared plus 9 times 0 minus 10. I see all of that goes away, and I would be left with negative. Pick a number greater than 1 over here, so I'll just pick 2. 2 squared plus 9 times 2 minus 10. 4 plus 18 minus 10. And again, I see that this is a positive number. They asked me for negative, so this was my interval where it was negative, where x was between negative 10 and 1. That is B. Number 9, use square roots to solve the equation. X squared equals negative 121 over the complex numbers. So x squared equals negative 121. I don't want x squared, I just want x, so I take the square root of both sides. So if x equals, I put the square root into the problem, so positive and negative, don't forget your two answers. 121 is a perfect square, that's 11. The negative underneath the radical came out as an I. So my two answers, positive and negative 11i. You could have written it as two answers, 11i and negative 11i, or you could have written it as positive or negative 11i. Either one of those are correct. Number 10, write the product 3i times 5 minus 3i in the form a plus bi. Product means multiply, so I'm just going to distribute. 3i times 5 gives me 15i. 3i times negative 3i gives me negative 9i squared. I squared always turn to -1. Remember, this is multiplying. -9 times -1, I have a 15i plus 9. Okay? A plus bi, the real number has to come first, so I have to rewrite that 9 plus 15i. So that is D. All right, number 11, write the quotient. 5 over 3 minus I in the form a plus bi. So again, okay, we are not allowed to have an I in the denominator. So to get it out of the denominator, I multiply by the conjugate. The conjugate of 3 minus I is just 3 plus I. Whatever I do to the denominator, I have to do to the numerator. So on top, distribute our 5. So I get 15 plus 5i over. On the bottom, I'm going to use our shortcut for conjugates. Our shortcut says the first term squared, so 3 squared is 9. Always minus the second term squared, I squared. I squared always turns to -1. On top, I have 15 plus 5i over 9 plus 1, 10. I cannot leave my answer like that because I can simplify that. I can reduce it. Okay? So 15, 5, and 10, they all have a 5 in common. Okay? So if I take a 5 out of everything, I'm left with 3 plus I over 5. So, keep the 5 out. Over 2. Okay. Remember, this is the same thing. I can separate this. This is the same thing as saying 3 halves plus 1/2 I. There's my answer. Is in a plus bi form because my real number is first and my imaginary number is second. Right. Factor the expression x squared plus 36. It is a sum of squares, so I know it's going to factor 2 sets of parentheses. X and x, take the square root of both of them, but since, and I know one's plus and one's minus, but since it's a sum of squares, this one's going to have an I with it. So the square root of -36 is 6i, 6i, x plus 6i, x minus 6i, which is A. All right, our last question. A function is defined by the equation y equals x squared plus 5x plus 4. Which statements are true? Select all that apply. So I'm just going to read through what they give to me so I know what I'm looking for. The graph of the function has a minimum. Okay, so I know that I'm going to need to find my vertex. The equation written in vertex form is this. The graph of the function has this minimum, or the range of the function is all real numbers. I know I can go ahead and get rid of that because the range of a parabola is never all real numbers. My range is always restricted. It's the domain of a quadratic that is all real numbers. So first thing I want to do, find my vertex. So again, that's the formula, -b divided by 2a. Okay, so h equals, my b was 5, so -5 divided by 2 times a is 1. So -5 halves. Yay, we got a fraction. So up here, I'm just going to plug in vertex, -5 halves. So now I need to find the y value. So remember, to find the y value, I plug this in to the equation. So I get y equals -5 halves squared plus 5 times 5 halves plus 4. -5 halves squared, that turns to 25 fourths. 5 times 5 halves turns to 25 halves plus 4. I'm going to add all of these. I need a common denominator. My common denominator is going to be 4, so the 25 fourths stays. I'll work each of these over 4. I need to erase that. I put it 2, and then divided by 4. Okay. This one had a 2 in the denominator. I need it to be a 4, so I multiply by 2. So 2 times 2 gave me 4. I have to do that to the top. 25 times 2, 50. I need to put the, oh, and I just realized that this was a -5 halves, so sorry about that. That's going to make these subtractions. Negative. 4 over 1, so multiply by 4 is the same thing as 16 fourths. So then add here. So 25 minus 50 gives me -25. -25 and a positive 16 gives me -9 fourths. So my vertex is -5 halves negative 9/4. Okay. So let's see. The graph of the function has a minimum. Okay, I know it's going to be a minimum because the graph is opening up at y equals negative 9/4 when x is negative 5/2. Yes, because that's what I got for my vertex. And then it says, so I know that this one is not right. So now I have to check, would this be the vertex form of it? So if I plugged it in, f of x equals, okay, my x value was negative. It always goes in my parentheses, opposite x plus 5/2, quantity squared, and then minus 9/4. And that's exactly what they have here. So A and B were both correct. All right, that is the test review for Chapter 2, Sections 2.1 to 2.4.